Hello everyone, this is Arjav and I am going to give a presentation on the topic transmission of signals. Let us first talk about what is transmission medium. So it is a physical path between the transmitter and the receiver, or we can also define it as the channel through which data is sent from one place to another. So a transmission medium can be further divided into guided media and unguided media, the examples of which we are going to discuss in the coming slides. Guided media signal is directed and confined in a narrow pathway by using physical links or wired connections. So these are generally high speed, secure, and used for comparatively shorter distances. So our first example in the guided media is twisted pair, which consists of two conductors, usually made up of copper, each with its own plastic insulation twisted together to form a single media. Generally, several such pairs are bundled together in a protective sheath. The twisting is done to avoid electromagnetic interference. It is used for telephonic communications and most modern Ethernet networks as well. So it can be of two types: unshielded twisted pair (UTP) and shielded twisted pair (STP). So STP cable consists of a metal covering on each pair of cable. This covering is to block external electromagnetic interference, and therefore STP has higher data transmission rate than UTP. The shielding also eliminates crosstalk, but on the other side, it is very comparatively difficult to install and maintain STP. Uh, the case is easier with UTP, and also UTP is cheaper than STP. Next, we have coaxial cables, which are copper cables with better shielding than twisted pair cables. Uh, in coaxial cables, transmitted signals can travel over longer distances with minimum losses because of the better shielding. So it has higher bandwidth, it has better noise immunity, they are easier to install and expand, and they are relatively cheaper as well. So they are widely used in the television networks and cable TVs. Coming to its structure, it is made up of two copper conductors which are parallel to each other. Each has its own protective insulation covering. Uh, but there is a disadvantage with coaxial cable, and that is that a single cable failure can disrupt the entire network. Uh, Next, we have optical fiber cable. Uh, we have already studied that it uses the concept of total internal reflection, and the TIR makes sure that the light is confined inside the core. So the core, as you can see in the diagram, it is made up of thin glass or plastic, and it is covered by less dense plastic or less dense glass, which is called the cladding. These are used for transmission of large volumes of data. So there is a lot of increased capacity and bandwidth in the case of optical fiber cables, and there is very low signal attenuation. Attenuation means loss of signal. We are going to talk about it in the coming slides. So there is very less signal attenuation as there is minimum or no electromagnetic interference in this case. But however, there are certain problems with optical fiber cable. One of which is that it is very difficult and expensive to maintain and install optical fibers in the first place, and they are fragile as well. So fixing the cable requires a lot of expertise and time. Uh, Next, we are going to compare attenuation for the guided media. So what is attenuation? Attenuation is loss in the power of signal. Basically, when a signal is transmitted over a medium, it has to overcome the resistance of the medium, due to which it loses its energy. So there's a loss of energy. So attenuation is defined as mathematically as 10 log P2 over P1. So this P2 over P1, P2 is power of the output signal, P1 is power of the input signal. So it is a ratio, and which can be written as 20 log A2 over A1, because power is proportional to square of the amplitude. So A2 will be the amplitude of output signal and A1 will be the amplitude of input signal. So attenuation, usually we consider its unit as decibel over length of the medium. So it can be decibel over centimeter or decibel per kilometer. So in this graph, we have the graph of attenuation versus frequency for three of our guided media. So as you can see, in the case of twisted pair, we have with the increase in frequency, first of all, there is a general trend that with the increase in frequency, attenuation will increase. So in the case of twisted pair, attenuation increases exponentially with increase in frequency. In the case of coaxial cable, it increases almost linearly with frequency. The attenuation characteristic of optical cable is similar to that of band pass filter, and frequency band, uh, uh, small frequency band in the region of terahertz can be used for transmitting a signal which has low attenuation in the lower region of the parabola kind of curve. Uh, so that particular band, frequency band, can be used for transmission of signals. So now we will talk about unguided media. So unguided media, no physical medium is required. We will use electromagnetic signals for transmission of data over here, and it is used for larger distances where uh, setting up cable networks can be very expensive and almost impossible. So let us consider the electromagnetic spectrum. Uh, we'll try to identify various type of mediums and their frequency ranges in which they are used. So when we move on from radio to microwave and further to infrared, we'll observe that the wavelength will decrease and frequency will increase. So also we can observe that the range of optical fiber is in much higher frequency range. So that is why the increased capacity and the increased bandwidth, large data can be sent. So we'll talk about unguided media now in detail. So coming to radio wave, these are very easy to generate and can penetrate through buildings. The frequency range is around 3 kilohertz to 1 gigahertz. The wavelength is large, and also these are omnidirectional, which means that sending and receiving antennas should not be aligned to each other. So they can be facing anyways. But there's a disadvantage to this as well, as a lot of interference between the signals can occur. AM and FM radios as well as cordless phones use radio waves for transmission. Now coming to the microwave, frequency range is between gigahertz to a few gigahertz to 100 gigahertz. And in this case, in the case of microwave, there is line of sight transmission, which means sending and receiving antennas should be facing each other. They need to be aligned to each other. So there is point to point transition of the signal. These media is used in mobile phone communication and television distribution. Next, we have infrared. Frequency range is now a bit high, from 100 gigahertz to 100 terahertz. It is used for very short distance communication, and it cannot penetrate through obstacles. So it is because of the it cannot penetrate obstacles because of very short wavelength. It is used for communications like our TV remotes or wireless speakers, mouse, keyboard, the computer peripherals, wireless, etc. So thank you. This is the end.